Okay, so today we are here to discuss the third method of DFA minimization. So we have this problem here. This NFA is given, and we have to convert this NFA to DFA. And once our NFA is converted to DFA, then we will minimize that DFA using the third method. So for that, you know that for a resultant DFA, the input alphabet will remain same as what we were having in our NFA. Initial state will also remain same as our NFA, and Q dash is nothing but the final or a set of states for the resultant DFA. That is it. That is the reason it is marked as Q dash. So you know that the NFA have the power set of Q. So now here, because we have four states in NFA, P, Q, R, S. So its power set will have 2 to the power 4, that which is equal to 16. So that many number of states we will be having in the NFA, including your empty set 5. And in DFA, because there is no empty set, so if we'll remove the empty set 5, then whatever we will get, that is remaining 15 states, can be the part of your Q dash. And now, because these many states we have in the resultant DFA, we need to find the transition from these states on all possible inputs. So here possible inputs are 0 and 1. So if for PQRS, the transition on input symbol 0 and 1, it is directly given in the transition table, and that you can identify. But when you have a combination states like PQRS or PQR, PQS, so for this combination state, how you will find the transition? Because these are the states of DFA. So for these states of DFA, how we will find the transition on input symbol 0 and 1. So here is an example. So if you have PQR, let's consider this as a state, give input 0. So how you will give the input 0 to PQR? You will give input 0 to P, you will give input 0 to Q, you will give input 0 to R. And then their transitions, that is transition of P on input symbol 0, union transition of Q on input symbol 0, union transition of R on input symbol 0. So we will have the union of this, and the final answer which we are getting is PQRS. So in the resultant DFA, from state PQR on input symbol 0, you will be transiting to the state PQRS. And this way, you have to find out the transitions for all these steps. And the final answer is here. Okay, once we have evaluated the transition on input symbol 0 and 1 for all the states in the resultant DFA, now it's time for DFA minimization. So apply the DFA minimization rules on this given state transition table of resultant DFA and try to minimize it. So as per the DFA minimization rules, we have to find the equivalent states first, and the states which have the transition on the same state on the same input symbols, and if the type of those both states is same, either type in the sense either whether they are final or non-final state. So if the type is also same, then we will call them as a equivalent state, right? So for that, first of all, just check the transitions, if they have same transitions on the input symbol. If the transitions are same, then we will check their type. Here you could see that the star mark is here. The star mark indicates that these states are final states, and where you will not have, where you will not find the star mark, it means those states are non-final states. So let's take the transition. So you can see that on state number 4, S. So on input symbol 0 and 1, there is a transition on state S. And on state number 10, that is RS, again on input symbol 0 and 1, the transition is same. So the transitions for these two states are same. And now if you'll check their type, you'll see that the state number 4 and state number 10 both are final states. So their type is also same. It means we can say that state 4 and state 10 are the equivalent states. So it means either we can replace 4 by 10 or we can replace 10 by 4. Then second, if you will check, if you'll say check this state number 7, which is PS. So to this state PS, after giving input 0, you are transiting to PQS, and on input symbol 1, you are transiting to PS state. Now same transition you will find here, state number 13, which is PRS state. To this, if you will give input 0, you are moving to PQS, which is same as state 7. And on input 1, you are moving to state PS, which is also again same as state number 7. And for these two states, to declare them as an equivalent state, their type should be 7. Their type should be same. So state number 7, that is PS, is a final state, and state number 13, which is PRS, it is also final state. So again, these two states are equivalent. Here also you can replace 7 by 13 or 13 by 7. Next, if we'll say state number 9, again you could see state number 9 and state number 14. So here their transitions are same. And if you check their type, so both are final states. Then if you check state number 12 and 15. So if you see here, their transitions are same. State number 12 and state number 15, 12 and 15. So their transitions are same and their type is also same. Both are final state. So 12 and 15 are also equivalent state, and you can replace one with another. So after replacement, you can see here, here we got this as a minimized DFA, right? So after replacement here, you can see what we have done is the lower states, the states with the lower number, those are remained, those we kept in the state transition table, and higher state or the states with a higher number, those are replaced. So accordingly, you will find 4, if you'll say 4 and 10, so 10 is replaced by 4 and 7 is replaced, sorry, 13 is replaced by 7, then 14 is replaced by 9 and 15 is replaced by 12, and 10 is replaced by 4. So this is how it is done. So when you are replacing, you know that when you replace this 10, see this entire row will get removed. So this 10, this RS, this row, this entire row will get removed. Wherever in this complete transition table you have RS, that will get replaced with S, right? Wherever you have RS, that will get replaced. So here we have RS. So this RS, it will get replaced by S, and here you will find instead of 10, here it will be 4. Again, you have here RS. So this RS, it will get replaced by S, and here in parenthesis, you will have 4. Similarly, same thing will be done for all the remaining states, and final, after this replacement, what we are getting is this. So once this replacement is done, again we need to check if there are, after these modifications, if we are getting any new uh, equivalent states or not. So you can see here, if we'll say state number 7 and 12. So their transition is same. State 7 on 0, it is transiting to 12, and state 7 on 1, it is transiting to 7 itself, and state 12 on 0 and 1, it is transiting to 12 and 7 respectively. And their type is also same, both are final states. So we can say these two are equivalent states. So you can replace either 7 by 12 or 12 by 7. Then again, we have one more state which is common. If you'll say state number 9 and state number 4. So here these two states, they have same transitions and their type is also same, both are final. So again replace 4 by 9 or 9 by 4. So as per our earlier trick, here also we'll keep our lower states as it is and higher states we will remove. So we will remove the 9 and 12. So wherever you have 9, that will get replaced by 4, and wherever you have 12, that will get replaced by 7, and the final output you can see here. Once it is done, again you can check if you have any equivalent states. If you have, again we will have to repeat the same procedure. But now here we don't have equivalent states. And once it is done, on the basis of this, you can draw the state transition graph. So this is what you will get here. And here you could see that here we got this diagram in two parts, but this part of this, you can see that there you can't reach to any one of these states from the initial states. So from state 1, there is no path where you can reach to 2, 3, 4 or 8, and that is the reason it is removed from the, you can also call them as a dead states, because you cannot reach to these states. There is no path where with the help of which you can reach this second part of the transition graph, and that is the reason it is completely removed. And the final minimized DFA will have only 5 states instead of 15. So this is how you can minimize your DFA with the help of this third method.